All right. So, hello everyone and welcome back. So, I was supposed to actually do this video yesterday. But ayun nga, since magkasakaso ng PS1, so it was delayed. But still, we're doing it now. No. So, ayun. We'll be discussing derivation, specifically yung ating undamped free vibration. Right? In which yung ating gagamiting example or yung pinaka-discuss natin is the spring mass model. Now, yung ating spring mass model is one that operates on a simple harmonic motion. And yung ating simple harmonic motion is a type of periodic motion. Now, what else? When we have a simple harmonic motion, so bilisan natin ang ta. So, yung ating acceleration that is directly proportional to the displacement. But gawin natin siyang negative. Why? Because it is always in the opposite direction. Because, ayun nga, whenever the displacement is less than zero, yung ating acceleration will be going up or it's always positive. So, mapapakita natin yan. So, mas ma-appreciate natin yan when we draw our spring mass system. Okay? So, yung ating acceleration, mag-introduce tayo ng proportionality constant to make it an equality that is equal to yung ating omega squared x, in which itong ating omega squared, that is what we call the angular frequency. No, and yung kanyang unit is watt per second. Or that is 7 raised to negative 1 or 1 over second. Ayan. And then nga, lagay tayo ng example. Let's say I have a spring mass system. So, isa natin. Say, ayan. And then, wala tayo na spring. So, gawin natin simple. Yan. And let's say it is connected to a block. And itong pangalawa naman is kapag nag-apply tayo ng tensile force dun sa ating spring and mag-extend siya. Ayan. Then we have the block. Alright. So, lagay natin yung kanyang properties. So, we have the spring constant present in both of these. And we have the mass of the block, let's say. Now, yung ating block, ito yung kanyang initial position. So, dito yan. Yan. It is where x is equal to 0. And let's say, di ba hindi lang natin yung ating spring. So, hindi ganun yan. That is our change in position, delta x. And itong range na to, this is what we call the amplitude. And we also have yung ating spring force. So, nilagay natin lang dito since wala naman yung present na spring force dito since we're not applying any forces to it. So, kasi meron dito spring force. So, di ba pinitawan mo yung ating block, it will move up. Now, again, our displacement is negative, but our acceleration is positive. No? So this signifies yung ating proportionality earlier that acceleration is directly proportional to displacement. And whenever bababa yung ating spring, or bababa yung ating block, yung kanyang displacement is positive, but the acceleration is negative. Again, let us define yung mga variables dito. Of course, yung ating m, that is just the mass. The k is the spring constant. And yung at x is equal to 0, that is what we call the equilibrium position. Okay? And yung ating Fs, that is spring force. Ayun yung ating spring force, that is a type of a restoring force. What we mean by a restoring force, that is always directed to the equilibrium. Kasi natin. Equilibrium. Ayan. And of course, yung ating spring force, as we have previously discussed, yan yung ating Hooke's law, negative kx. Ayan. So, that is the principle we established with yung ating spring mass model. Now we'll move on to the derivation of the free vibration in terms of the spring mass model. Now, we are considering yung ating Newton's second law. In which our net force, the net force that is equal to the product of the mass and the acceleration. Again, equate natin siya into our Hooke's law, the spring force, which is negative kx. Now, we will treat yung ating acceleration as the second derivative of x with respect to time. Or we can just denote this as x double prime para uniform ang ating variables. So we have negative kx that is equal to mx double prime. And equating this to 0, we have mx double prime plus kx that is equal to 0. Now, ang ginawa dun sa lesson natin yesterday is that parang naging persistent yung use ng ating m at k. But for this one, pagsasamahin natin siya. So, we divide both sides by m. So, cancel to. And we have x double prime plus k over m x. No, k over m x equals 0. And itong ating k over m, that is our angular frequency. Okay? And yun yung ating omega. So, gagamitin natin siya ng initial condition. So, 0. So, just put this as sub-0 squared. Or omega naught. Omega naught squared. Okay? So, siya magiging x double prime plus omega naught squared x equals 0. Ngayon, we can see that yung kanyang format, so ito sa format of am squared plus pm plus c equals 0. Ito yung ating characteristic equation. Now, as we have noticed, this is a homogeneous DE with linear coefficients. And yung kanyang case, since we have a square here, that is case 3. If you recall, case 3 is we have complex conjugate Which yung kanyang format is along the lines of m equals a plus or minus b I. So we have an imaginary number. Okay? So rewrite natin siya. Let's say in terms of r, since we'll be dealing with angles later. So we have r squared plus omega naught squared equals 0. Napagkailan natin yung kanyang root. Then we have r equals plus or minus omega naught I. Okay? And susundin natin yung general solution dito. Ang kanyang general solution is that y is equal to a raised to a x. Then we multiply that by c1 cosine of bx, let's say ito yung constant, plus c2 sine of bx. This is what we commonly refer to as Euler's identity. I also think I have a video on this, so if you want to know more, please check that out. And ayun, considering yung ating displacement as a function of time, therefore, it is equal to c1 cosine of omega naught t plus c2 sine omega naught t, where yung ating c1 and c2 are defined by initial conditions. Now, since we're dealing with vibration engineering, we want to convert it into something that we can actually use instead of just a general solution. So, convert natin siya into our amplitude phase form. Yeah. In which yung ating amplitude phase form, that is x as a function of time, that is equal to a cosine of omega naught t. And now, this could be plus or minus. But in this case, gamit tayo ng plus phi. Okay? So, explain natin mamaya kung bakit pwede siyang plus or minus. Alright. So, we will use our general solution here. So, copy lang natin to. Wait. Okay. Let's just copy this. Yeah. Now, ang gagawin natin dito, we are going to multiply this by a conjugate. No. Since yung ating A earlier, di ba, naglagay ako ng A sa equation, yung ating A, that is actually yung ating amplitude. And since we are dealing with yung ating sines and cosines, so we can also introduce the Pythagorean theorem. So, i-model natin siya after nun. So, A, that will be c1 squared plus c2 squared and then the square root. Yan. Yan yung ating basis dito. And we will multiply this by the conjugate. Meaning, multiply both sides by 1. But yung ating 1 is the square root of c1 squared plus c2 squared, basically. And we can do that because we're not really violating any laws of mathematics. Ayun. So, factor out natin siya. No. So, this is just the same as A over A. Ayun. So, factor out na natin siya. Yung nating A, that is equal to, or rather, multiplied to C1 over A cosine omega naught T plus C2 over A sine omega naught T. Yeah. And para makuha natin yung gusto nating equation, we will use an identity. So, magsasa tayo ng identity that is yung ating sum and difference of sines and cosines. So, in this case, ang gusto natin makuha is a plus dun sa omega naught t plus phi. So, the format na gagamitan natin ay whenever we have, let's say, cosine of A multiplied by a cosine of B minus sine of A multiplied by sine of B, that is equal to cosine of A plus B. Yan. So, gusto natin itong gawing cosine and we want this to be sine. Okay? So, set lang natin siya doon sa parameter na yan. Let's do C1 over A, that is equal to cosine of phi, and then C2 over A, that is equal to negative sine phi. Ayan. So, we can rewrite this with the format of A cosine phi cosine omega naught t plus, or actually minus rather, sine phi sine omega naught t. And makukuha natin yung format na to. Therefore, x t, that is equal to A, and then this is, or actually this is just cosine. Cosine omega naught t plus phi. Now, dito nagkakatalo yung ating units, yung ating operation rather, whether it is plus or minus. Since gusto natin makuha yung value ng phi, which is yung ating phase angle. Since yung ating A, we modeled it by the Pythagorean theorem, so gamit na lang tayo ng trigonometry here. So, mirror lang din natin. So, phi, that is, baba natin ang ito. Okay. So, phi, that is equal to the inverse tangent, arctan, of sine and cosine. Ayan. And ito na yung ating may equation dito. Nakasat na. So, plug in na lang natin. But in this case, since theta over A yan yung positive and yung negative, so it must be negative sign. So, phi, that's equal to inverse tangent of, makacancel na yung A. No, makacancel na to. So, this is negative C2 over C1. And that is because yung sa ating ginamit na identity dito. No. So, if we used one that would yield positive, so ito yung magiging negative. That's why I emphasized on the sign earlier. In which, kapag ito yung pag-positive, and kapag siya yung negative, pag negative yung sign dito, then we just oppose the sign. Inverse tangent of C2 over C1. Again, it's a matter of perspective since we're dealing with wavelengths, dealing with waves, no? So, ayun, to clear the confusion, yan yun. And this is our amplitude phase form. Ayan. And before we move on to solving problems, let us further explain yung behavior ng ating wave. So, this is position as a function of time. Function of time. And this is velocity as a function of time. Yeah. So you can see, this is a sine wave. This is a cosine wave. That is because the derivative of sine is cosine. And the derivative of the displacement is the velocity. So, ayan yun. And again, if you take the second derivative of sine, we will go back to sine. So, we also say that this is the acceleration. since yung atin namang max displacement, that is also our maximum acceleration. Right? Then you have the amplitude, and then you have the period, t. No? So this is the time it takes to complete one cycle. Yun. And as you can see, whenever the position is at the maximum displacement, the velocity is zero. Dahil titigil siya and then bababa na. As previously discussed dun sa ating, acceleration is directly proportional to the opposite direction. Ayun. So, lagyan natin yung equations dito. Right? So, x of t, that is equal to amplitude times cosine of omega naught t plus phi. Ayan. Now, for the velocity, we just pick the derivative. Okay. This is just the chain rule. So, derivative nitong loob, and then yung derivative nito. So, multiply natin siya. So, we have omega naught a, which is sine, no? Sine, and then omega naught plus phi. Ayun. And I believe that, hold on. Yan. So, this will be negative 1. And then we have acceleration. This will be negative as well. Ayan. Ayan. So we can say that yung ating Vmax and yung ating Amax, that is just yung ating at a general form, no? So it is a matter of perspective. So it is negative because we're projecting it downward. So, but in general, it is omega naught A times omega naught squared A. So bakit nawala to? Itong mga part na to. That is because yung range ng ating sine and cosine is only from 1 to negative 1. 1 to negative 1. Yun lang yung range niya. Therefore, if we equate this into, let's say, 1 or negative 1, this will either be negative or positive. No. In this case, positive siya because it is a maximum. Kapag negative siya, no, that is your Vmin. And so on. Yan. No. So when it goes away from the initial point or the equilibrium, bumabagal siya. And kapag papunta siya sa ating equilibrium, bibili siya. Ayun. And I do believe we can proceed to our problem solving. So ito din naman yung mga na-discuss sa klase. So ayun. So if you solve this, then goods ka na. But I'll try a different approach here. No, let's try a different approach. So, medyo iba lang natin yung pinapahanap. So, diba meron tayong AB. So, gawin natin siyang B and C. And yung ating A is to find the equation of motion. So, ay nga, we will treat yung ating mass, as a weight. No? Alright? So, yung ating given. We have the weight to be 30 pounds. And yung ating displacement, that is downward, -1 inch. So, para uniform yung ating units, convert na natin siya muna into feet. Yan. As well as yung ating spring constant. So, we'll just multiply this by 12. So, that is 40 pounds per feet. Yeah. And PO, that is 0. Yeah. And we have our find. So, basahin muna natin pala yung problem. Nakalimutan na natin. So, 30-pound block is supported by the spring shown. If the block is moved 1 inch vertically downward from its equilibrium position and released, determine A, the equation of motion. No. B, basta natin itong 5. Yeah. B, the period and frequency of the resulting motion. And C, velocity and acceleration of the block in inches per second and inch per second squared, respectively after 3 seconds. Yan. So, ito yung ating 5. So, we have the period. Ilagyan natin yung kanyang so the period T and yung frequency omega n. Yeah. And actually, ang ipala natin ay ito. So, this is B. A, equation of motion. B ito, and then C is yung ating velocity and acceleration at time equals 3 seconds. Of course, V equals inch per second, and then yung ating acceleration ay in inches per second squared. Ayun. Let's solve. So, first, we convert yung ating weight. So, mass equals weight divided by the gravitational constant, or the acceleration due to gravity. So, we have 30. Since weight, i-treat na natin siya as a poundal. A poundal is pound-feet per second squared. This is what we call the poundal. Right? And then, we have 32.2 feet per second squared. Yeah. And gawin natin, may makasal na to, we're left with the mass. So, doing this, we end up with 0.931. Round off natin into 4 decimal places. But, we store the whole value. No? Para uniform yung ating computation, we store the whole value into, let's say, P. Huwag muna sa A, since malilito tayo sa amplitude. This is pound. Yan. Now, we proceed with the equation of motion. So, ito yung ating part A. Yan. So, we have M x double prime plus kx equals 0. Ito yung ating differential equation. And yung ating mass, nakastore kay B. X double prime plus yung ating spring constant, i-convert natin into 240. X equals 0. Ngayon, divide natin both sides by B. So, makancel na to. And we end up with x double prime plus 240 over b, that is 257.6. X equals 0. Yan. Now, to get the frequency, makuha natin siya. This is the frequency. So, hold on. And this is the frequency. Omega n. So, yung unit niya dito, since this is squared already, naka-square na siya, kuha natin yung square root. So, ang unit niya is second is to negative 2. Okay, so, if natin yung square root, we can reduce that. Okay? So, that is equal to square root of 257.6. And we end up with approximately, round off na uli natin siya into 4 decimal places, but we will store the whole value. So that is 16.0499 rad per second. Since ang unit niya is 1 over S na. Ayan. Store natin siya kay C. Okay? And ayun nga pala, for part A, ito na yung ating equation of motion. Yes. So, gano'n na siya katali. Okay. Now, kuha natin yung period. Okay? So, the period is actually, ang pinapangarap nga pala is frequency. Okay. The natural frequency, F. This is just the angular frequency. Okay, so I stand corrected there. So, that is 2 pi over ating angular frequency. That is just 2 pi rad, di ba yun yung unit niya? And then, we have store yun kay C, yung ating angular frequency, in which that is in rad per second. So, makakancel na to. And we end up with, that is 0.3915 approximately seconds. Store natin to kay D. And yung ating frequency, that's just the inverse. No. This is the reciprocal, rather, the reciprocal. So 1 over D. That is equal to 2.5544. And since frequency siya ay frequency, although we have the same unit, so that is 1 over second, but is still that we can equate that into hertz. Yeah. So this is our answer so far. What else? The velocity and acceleration. Okay. So, okay, next page. So from the general solution, in which x of t, that is equal to c1 cosine of omega n t plus c2 sine omega n t. Yan. Yun yung ating general solution, di ba? Now we are given initial conditions. At time equals 0, x is, meron siya initial displacement of 1 over 12 feet. Right? But in this case, since ang hinihingi naman niya ay yung velocity and acceleration in inch per second and inches per second squared, hindi gawin na natin is negative 1 inch. Yun na lang. And our velocity is 0. Ayan. Therefore, if we set yung ating time equals 0, so we have negative 1, and that is equal to, pag plug in tayo ng 0 dito, this will be 1, this will be 0. Therefore, nagtira ay C1. So, negative 1 is C1. Okay? And to get C2, we set the velocity into 0, then plug in natin. So, we have kung natin yung derivative, that's negative C1, right? Yeah, since magiging 0 lang naman siya, since gagamit pa tayo ng chain rule. No, gagamit tayo ng chain rule. But, in the end, magiging 0 naman siya, kung na siya complicate. It should just be 0. Or actually, yung ating b sub 0 ay iset na natin siya into C2 equals 0. Since masi 0 din naman siya, so there's no point in doing the solution there. Ayun. Yeah, explain din natin para hindi tayo malito. Since iwakuha natin yung derivative. So, magiging negative C1 sine yan. Magiging 0 plus C2 cosine yan. This is 0 because yung ating sine 0, of course 0, and then this is 1. But 0 lang din naman yung kalalagyan niya. So, that's that. Ayun. Now, we just plug in our values, right? So, x of t, that is, ano siya? Negative, right? Since, multiply natin siya by negative 1, so it's negative. Cosine, ct, this is in inches, right? Since, ito lang matitira dito, right? Then, multiply pa siya by negative, and then ito ay plug in natin yung ating c dito. So, ayun. Taking the derivative, dito na tayo mag-apply ng chain rule. So, this is c. Negative din siya. So, negative is negative, positive. C sine. And then, ct. Yan. This is in inches per second. And, yeah, acceleration, that is equal to negative na siya. This is c squared cosine of ct. This is in inches per second squared. Yeah. And at time is equal to 3 seconds. So, we have x of 3 displace the position, and then the velocity, and then the acceleration. So, plug in lang dun sa value ng t. Since lahat naman to meron na. So, makuha nating displacement is around 0.5183 inches. It's going up. So, if it is going up, that must mean na yung ating velocity and acceleration dapat pababa. So, verify natin. Since ayun nga, yung nagli-lead lang siya into the proportionality that acceleration is inversely proportional with position. Yun. Then ito ay negative. So, tama. 13.7254 inches per second squared. And this is also negative. This is negative 133.5268 inches per second squared. So, ito yung answers natin. This is part C. Part C. And dito ay this is part A, this is part B. Yan. Okay? So, gano'n lang siya simple. Moving on, this is the last problem. Yan. 1.4 kilogram block is supported as shown by a spring constant K equals 400 Newton per meter, which act in tension or compression. The block is in its equilibrium position when it is struck from below by a hammer, which impart to the block an upward velocity of 2.5 meters per second. Determine A. Yeah, so that have been given. So we have mass of 1.4 kilogram. And then we have a spring constant of 400 Newton per meter. Tapos, we have an initial velocity. So, at time equals 0, x equals 0, velocity is equal to 2.5 meters per second. And we're asked to find A. No. So for A, the time at yung kanyang displacement ay equals sa 60 millimeters. So that is 0.06 meters. And then B. Actually, ang naka-state lang dito, I think sa problem is maximum. But still, same lang din naman siya, actually. So, V min, V max, E min, A max. So, ma-illustrate tayo siya later. So, ayun. I think we can solve. So first, the angular frequency, square root of k over n. That is equal to 400 over 1.4 square root. That is equal to 16.9031 approximately rad per second. Ngayon, stir natin siya kay A. Okay? Now, balikan natin yung ating general solution. Right? General solution. So, x of t, that is equal to C1 cosine omega n. Mukha na siyang W. So, C2 sine, then it is omega n t. Yeah. Taking the first derivative, this will be negative, the chain rule, omega n C1 sine omega n t plus C2, or actually plus the omega n C2 cosine of omega n t. Yan. So, dito tayo mag-apply mamaya ng ating boundary conditions and yun nakuha nating values. So, first, let's solve for C1 and C2 at time equals 0. The displacement is 0. So, yung ating C1, diba, dito natin siya i-solve. This will be 1. This will be 0. Mapag-sunod natin. So, and this is 0. Yan. So, C1 equals 0. And we have an initial velocity. Yeah. So, for C2, since the initial velocity is 2.5 meters per second, pwede natin gawin ay 2.5, that is equal to the C1, since 0 siya, wala na siya. So we have yung second term na lang. Ito. Omega n C2 cosine. And ito ay omega n times 0. So this will be 1. Right? Therefore, we have 2.5 is equal to omega n C2. And C2 is equal to 2.5 over omega n. Ayan ang ating omega n, restore natin siya. So, it will be 2.5, this is meters per second, all over, nasa A siya. Ayan, nakastore kay A. This is rad per second. Now, this is basically just meter times inverse second. So, second raised to negative 1. This is just second raised to negative 1. Then cancel that out. Literal sa atin ay meter. Right? So, C2 is equal to 0.1479 meter. Store natin siya kay B. Again, ang i-store natin ay yung whole value niya. Now, we have C1 and C2. We can apply our boundary conditions and ating rules. So, x position as a function of time, yung ating C2, no? Since ito lang yung natira, C2 ay B, right? B sine, and then nakastore kay A yung ating angular frequency times the time. Yan. And taking its derivative, what's velocity? Ayan, yung ating 2.5, gamitin na natin to. Because, di ba mag-store din tayo dito ng value. Di ba ito yung A, then ito yung B. Siya naman ay equal into 2.5. Then, mangyari lang din dito, that is A times B. Right? So, gawin na natin siyang 2.5 since equal naman siya doon. So, this is 2.5 cosine, right? And this is 80, right? Since negative, right. So, tama. And then, for acceleration, that is negative 2.5 A. Yan. Sine of 80. Yan, ito yung equations na gamitin natin. Ngayon, solve natin yung time. Okay? So, pwede natin i-shift solve. No, since ang magiging itsura niya ay 0.06 meter is equal to B sine 80. And we can shift solve. But for the sake of it, let's just solve it manually. So, yung muna natin ay i-isolate yung ating t. So, first, divide both sides by b. So, we have sine of a t that is equal into 0.06 meter, and we have p meter cancel. Ayan. And again, we multiply both sides by the arc sine, by inverse sine. So making equation dito is that t is equal to, tapos i-divide pa natin siya by a. Okay? So this is sine, arc sine, or inverse sine of 0.06 over b. Or if nakuha mo na yung value dito, pwede mo na siyang store, tapos ilagay mo na lang dito yan. And this is over a, siya ay nakarad per second, so that is inverse sine. And siya ay 1 over second, marireciprocate magiging second. So, tama siya with time. So, therefore, yung ating time, that is equal to 0.0247 seconds approximately. And ito yung ating A, di ba? Now for B, again, since we have the equations here, basically, yung ating max and minimum velocity A ito. Tapos yung ating minimum and maximum acceleration ay ito. Okay? So, since itong ating trig functions, right? Yung ating trig functions, they're only at minimum and maximum whenever they are equal into 1 or -1. So, yun lang yun. Okay? So, for B, yung ating Vmin, that is just -2.5 meters per second. Vmax, that is just 2.5 meters per second. And yung ating minimum acceleration, okay, that is -42.26 meters per second squared. And yung ating maximum ay 42.26 meters per second squared. Although, if there are any mistakes, then just tell me in the comment section below if may nakaligtaan ako dito sa problem na to. But I believe this is the reasoning here. Yun. So, nasagot naman natin siya. So, I think that's it for this video. So, again, I pretty much have to go to school later. So, ayun. Ito na yung sagot dito sa problems na to. And then ito. Yeah, so I do hope that you've learned something from this video, from the concepts, the derivations, the problem solving of our free vibration. Right? So, ayun lang naman. Thank you for tuning in, and I'll see you guys later sa school. Alright, so that's it. Thank you guys, and of course, happy learning.